Hi there, my name is Eric, and this is part one of a presentation called Making a Correct Exposure. A little review first. An exposure in photography is the correct amount of light hitting a sensor or film and is based on four things: the amount of available or added light, the camera's shutter speed, the camera's aperture, the camera's ISO. The correct amount of light hitting the sensor creates a proper exposure. Too much light causes an overexposure. Too little light causes an underexposure. The camera is designed to read light. Modern cameras have the ability to read light coming into them. The problem is that not all parts of a scene may be evenly illuminated. This usually results in part or all of the scene receiving an incorrect exposure. Even when light may be well balanced, the objects may reflect more light than an average scene would. Snow is a typical example of this. This may cause the camera to underestimate the exposure, to let less light in than is needed. This results in underexposed shots, such as this. So on the left side, the largely white scene makes the camera think that there is needs to have less light in it than it should. So that produces an underexposed shot. You can see the flat line on the histogram. To get a proper exposure, the photographer has to alter it to let more light in. Dark scenes are often interpreted poorly as well. Interpretation and action are often needed to correct improper exposure settings. So what's going on and how do you fix it? So there's a wide range of mechanisms and algorithms used to determine what an exposure value is for any one shot. We're not going to go into those. We're going to use a slightly different model instead, but it will work for our purposes. So to do this, I'm going to ask you to either get your camera and or just do a thought experiment. So what I would like you to do is to take your camera, put it on aperture priority, and lower the aperture value so it's as low as possible, and pay attention to the shutter speed. If the meter reading goes off, which it likely will, just touch the shutter button to reactivate the meter. So at this point, what we're going to do now is we're going to take a look at things around the room or wherever you happen to be. Stay in one position and move the camera about, paying attention to what's happening to the shutter speed. You'll notice it goes up and it goes down. Get off from where you are and move around and point the camera directly at different areas of lighting. Not so much lighting, but walls and floors and desks and that kind of thing. And what you're going to notice is that the shutter speed is going to change, sometimes by quite a bit. Take a look at the picture I've put on this slide, and you'll notice where the stars are. If you were to take a camera and meter off each of those sections, you would find that you would get different shutter speed readings. So the question is, well, aren't they all lit by this exact same light? Isn't the amount of light hitting them all the same? And the answer is yes. So then what's going on? Why is it that all these different things are giving different meter readings if it's the exact same amount of light? And that's because the camera's meter measures reflected light. It doesn't measure incident light coming in, it measures reflected light coming out. So this light that comes off reflected surfaces, things like the car, which is quite dark, or bright things like the white framed area. Okay, so what's basically happening is that the camera is averaging all of these values, and then it gives a meter reading. So when the average is not representative of the actual situation, the meter reading may be incorrect for that scene. So in this situation, it might be too bright. Snow is often the typical of that. This is an obsidian flow, which is very, very dark, and it causes the opposite problem. Sand causes another issue. Bright skies cause a problem. And a lot of skyline reflections off water, all that kind of stuff. So how do you tell then? What are you supposed to do? How do you know if your meter reading is true or not? Well, one of the tricks is to pay attention to your histogram. A histogram is just a graph of the number of pixels of shade groups in a shot. The histogram to the left is of the associated picture. Pixels to the left are darker. Pixels to the right are lighter. The far left column shows black pixels, and the far right column shows white pixels. Mid values are shades in between, going from dark gray to mid gray to light gray. Now the trick with histograms is to look at trends, and this is very important. If you have a histogram display in your camera, turn it on. You're going to have to do that through your menu setting. You might be able to do it through a few other methods, but if you don't know, you can look it up. You may even have a live histogram display, which is very handy. Looking at these things, we're going to determine what an overexposed, an underexposed, or a properly exposed histogram looks like. So if you look at the example far right, there are very few highlights. Okay, so the white areas is flat and pushed on the right side of the same histogram, the left side. Those values are pushed up against the wall. An overexposed image that's in the center is opposite of the left. It's got very few dark values and lots of values that are too bright. They've pushed up against the wall on the other side. A properly exposed image typically is edge to edge. So have a look at these two images. Which one is underexposed? If you look at the histogram on the one on the left, you can see that blank side with the pushed up values on the other side. Okay, if you look at the image on the right, you can see that it's an edge-to-edge histogram. This is an overexposure, same sort of idea. You can see that there's a flat line on the left side of the histogram, and it's pushed up against the wall on the right. And on the other one, the histogram is edge to edge. So the simple trick to interpreting histograms then is to look for trends. Left side shows dark values, right side shows light values. Histograms going to edge suggest properly exposed images. Histograms pushed up to the left and blanked on the right are underexposed. Histograms pushed up to the right, blank on the left, are overexposed. There are various ways to correct all of this, but all of them require that you do something. So these are some of the things that you can try. Exposure compensation, exposure lock, bracketing, using scene auto exposure mode, using manual exposure mode, shooting in RAW, and post-correcting later. This is the end of part 1. I'm going to do a second part that will continue after this.